Hi everyone. This is the second video where Sally and I, this is, programming C Sharp with Sally, where we, start, continue our sessions into learning about, C Sharp as a programming language. Just so you understand, when I speak, I speak about programming and software engineering in general. It just so happens that the tool that I'm using to express my thoughts and my ideas is C Sharp. But of course, the concepts and the ideas that we're talking about in here is something that you can absolutely use in other programming languages like Python, Java, Scala, whatever programming closure, whatever programming language you want to use. You can absolutely reflect and use the same ideas into these languages. Okay, Sally, today we're going to talk a little bit about some theoretical stuff, and then we're going to jump into a little bit more complex stuff as we usually do. And then, feel free to interrupt at any point in time and ask me any questions. I'll be more than happy to kind of, answer these questions for you and provide more clarification. So,
Thank you.
okay,
Mhm.
what does every programming language out there has? What are the powers that every programming language out there has that we can use as tools to express a particular idea? Programming languages, there's something called flow control. Flow control meaning that, you're trying to describe a story, you're trying to describe a certain set of events. Remember when last time when we were writing our program that will be calculating the space, there's a set of flow in here. We went and defined a variable for a living room. We defined a racer chair, a kitchen chair, and a TV, and then we went in and we basically created another furniture piece like a bouncy castle. This is called the flow. This is a flow that's going on. It's how you're basically telling the story about, your program. What story are you trying to tell? For instance, if we go and write something as simple as, let me show you here. If we go and write something as simple as, consider that I have a kitchen chair and a racer chair and a TV. Find out whether these pieces of furniture fit in my room or not. This thought that I've written in here is exactly the equivalent of what I've written in here, one by one, right? Maybe with another line in here that says, and tell me, whether the pieces of furniture fit in my room or not, or something like that. Tell me here, meaning that go ahead and print a message, and print the result in there, right? So so this is basically a thought. This is what we call a thought, and this thought has been turned into code. This is the core of programming or software engineering in general. To have a thought, to have a solution for a problem, and then being able to translate that solution that you have in your head for that problem into code. Everybody actually is a software engineer. I'll tell you why. We solve problems all the time. Like, for instance, let's say you're going to the grocery store and you're basically saying, oh, I have that much space in my fridge, so I want to make sure I don't buy too much stuff that would potentially, go bad or basically spoil because there is no space for these things in my fridge. That's programming. That's engineering. You're basically going out there and calculating something, and you're basically saying, well, this is how I'm gonna solve this problem by making sure that I don't buy too much stuff so it fits in my fridge. Another example of this that we experience in our life is basically going and saying, well, there's that part that I just talked about that I call, in terms of flow, it's called a sequence of events, right? So I'm gonna go to the store, I'm gonna select enough stuff that would fit in my fridge, end of the day. But there are also other flows that happen in our logic. Another flow that is very common in our logic is the selection flow. This selection flow is when you go and say, I'm gonna text my friend John, right? And if John responds, then maybe we will go out for coffee. And if he doesn't, then I will just watch TV. This
Mm.
is programming. This is literally programming. This is you going and saying, okay, I'm going to trigger an event. I'm going to say something. And based on that something, based on the result of that something, I will determine whether I need to take one action or another. You saw that very clearly in this area here when we went and said, if the furniture size is less than the available space, then take one action. And if it's not, then take another action. That's what we call a selection flow. Basically, you're going and saying, this is your flow, and you're basically saying, I am controlling that flow and determining which route I need to take based on the outcome of a particular operation or of a particular input. The third and last aspect of programming is what we call iteration. What we call iteration is basically what we do every day. You wake up in the morning, you go to work, you finish work, you come back home, watch TV, go to bed. Wake up in the morning, go to work, come back from work, have dinner, watch TV, and go to sleep. This is called iteration. It happens every day in our life, right? Me and my friends are going to meet every weekend. This very session that you and I are having right now, it's a form of iteration. You and I said we're going to meet every day and we're going to talk about software engineering and programming. And, this is a form of iteration. So every day when Sally goes online, I'm going to join the session and I'm going to start talking to Sally about programming. See, there's nothing out there in this universe, of the known universe that we know of, that can go outside of these three categories of flows. And when I try to represent those, there was a previous session where I was talking about, flow control and, Pretty Blazor and, some other aspects in software engineering. This is how I represent those three things. And remember those forever because this is really the core of any programming language. Here's a box and here's a triangle. Sorry, here's a triangle here. Fix that guy a little bit like this. And there is a circle. And each one of those represents an aspect in any programming language. This is literally, there is no statement that a human being can make or action that we can take that doesn't fall within one of these three. The first one here, like I said, is the
Mhm.
sequencing, which is basically things go from the top to the bottom, A, B, C. No magic there, right? So in here, I'm gonna go here and represent this and say, well, there is A, sorry, and there is B, and from B to C, and there is no magic there, and then there is C. Let me zoom in a little bit. You told me yesterday that
Yeah, no, I get that.
like this. Okay. Right? A, B, C, no magic there. Just a flow, no magic. And this one here, it's a little bit different. In this one, it says based on A, determine whether you want to go the C route or the B route. See, so now it's different. It's not sequential anymore. It's selective. It's
Mhm.
basically saying based on what A situation is, determine to go this route or that route. So this piece is really important. That's what we call selection, like this, selection flow. The last flow is basically when we go and say, don't just go from A, like in here we said go A, B, C, and then exit, done, right? In here, we're basically going and saying, keep going from A to B and from B to C, and then back from C to A again, and then from A to B again, and so on and so forth. This is what we call iteration. Iteration. So this is basically, these are the main concepts or the pillars of programming language when we go and say, well, here is how we can express a thought or an idea. That thought or an idea, when you break it down to primitive categories of operations, it can't be anything except for these three things. Even at this very moment, like right now, I'm explaining these to you. This is sequential. I'm basically saying there's this type and this type and this type. That's sequential, right? And then based on whether you ask me a question or not, I were determined to go into further detail or continue in my
Mm.
sequential flow. Everything around us is like this, Sally. And there's nothing out there. And if you understand this part, this is really the core of engineering. If you know how to solve any problem in terms of these three aspects, this flow control, like computer scientists call them, if you can solve any problem like that, it's the easiest thing in the world. This is why when people come to me and they say, Hassan, what should I learn when I learn C sharp or when I learn a programming language? I always tell them, learn how to do sequencing, learn how to do selection, and learn how to do iteration. And we're going to talk in this series, we're going to talk about all the different kinds of, ways you can express a selection, all the kinds of different ways you can express an iteration. There are things called for loops, for each loops, while loops. There's all kinds of different things that programming languages provide today. Like today here, there's something called pattern matching. Sequencing is the easiest one of them all. You just go one, two, three, four, and you're done. You just, define a variable, give it a value, and then print it out. That's a sequence, right? Any questions about that part? Any questions at all in here?
You mentioned something like pattern matchings. I didn't catch that. So,
Yeah, yeah, pattern matching. It's like when you go and say, hey, I'm gonna send you a shape.
mhm,
Match that shape to shapes that are known to you. If it matches the pattern of any shape that you have, then
mhm.
go ahead and return the result for that shape. In programming, we go and say something like this. Let me show you what this looks like in programming. We can go up in here and say,
Or, that is in category of selection flow, right?
yeah, it's a category of the selection flow. That's right. So
Mm,
basically, an example of this would be something like this. Imagine if we have a function in here, public, something like this, public static, static string function. So it returns a string, and then this function says, are you Sally, for instance? And here's the name, right?
mm,
You can go up in here and do pattern matching, meaning this guy is going to return either true or false. Let's say it's going to return true or false. We can go up in here and say return, right? Name switch. And this is a modern C sharp, I think 8 or 9 kind of pattern where you go and say, if the name is Sally, then return true.
mm,
Otherwise, return false. This is an example of a selection pattern in programming languages. So it's taking this name and it's matching the pattern to the name. The pattern here is Sally. And
mm,
based on that pattern, it determines whether to return whether this person that is being passed in the value of their name, whether they're Sally or not.
mm.
Okay, and we're going to talk about all these kind of different, like, let's just, let me just, go through some of
Uh,
these types. Go ahead, go ahead, go
no, I
ahead.
got it. So I just the
Mhm.
word was new,
Yeah,
but
it's
I
a, it's
got the concept. Okay.
right. So the most common ones here is FL statements,
Mhm,
right? There is the switch case. Switch
mm,
case is considered a selection. There is something like pattern matching, like I said. So there is pattern matching,
mhm,
matching like this. There is, I guess, a ternary pattern, which are all technically true, false, ternary like this, which is basically, let me show you an example of ternary statements. Is when you go and say, here is where is the Visual Studio? Here you go. So a ternary statement is picking up that exact same statement in here and me going and saying, return, return, name equals Sally.
mhm,
If the name does equal Sally, then return true. Otherwise, return false,
like
like this.
conditional if
Hmm.
state.
Yeah,
Mm,
this is called a ternary statement,
mistake.
right? And you can also do a selection statement by simply just going and saying, hey, return true or false. If
Mhm,
it equals Sally, it's true or false. See how we can express the
mm,
exact same thought. You know, this is why I say, software engineers are, at some point in time, they are philosophers because they're thinking about logically about something.
mm,
But then sometimes they become poets because they have to make their code readable. They have to make their code easy to understand. And then
mhm,
also they come into another side and they become artists because they have to design interfaces and UI and mobile apps and all that. And it has to be pretty and enticing and attractive for people to actually use it and all that. Okay, so you have this guy. And then there is on the other side, On the other side of this, there are examples of iterations. What are good examples of iteration? Ah, well, there's a lot of those. Some of them are not very common than others. So for instance, there is the for loop, and there is for each loop. It's a little bit different. And then there is also while loop, right? And there's do while loop, right? And there's this while, do while, and then there's while, and then there is these what do you call it? Link expressions that we have today. A link expression is like a lambda expression that basically does the iteration for you. Underneath all of this, the ternary, the pattern matching, the switch, they usually go down to this original implementation, which is if else. The same thing happens with all of these. Originally, they come down to this original implementation, which is a for loop, right? It's basically a form of iteration. Now, if you understand this piece and you understand how this works, you can basically own the ability to break down any problem into a statement and breaking that statement into one of these patterns and then breaking these patterns into code. Yesterday when we came here, we said, "Hey, we have this problem," and I'm intentionally picking up like a vague shape, right? Like a cloud, right? And this is my problem, right? And then after I've done my problem, still a little bit vague, but I have a solution, right? And the solution here is, okay, I need to build a program to make sure that the every time I add a new furniture, I need to check whether I have space or not. So a little bit less vague, but kind of still vague, which is the solution. And then out of that solution, you start breaking it into one of these famous three patterns to solve our problem, right? If you look at our code from yesterday, and I'm going to show you in a second, if you look at our code yesterday, here's this guy, and then here's the sequencing piece. What did we do yesterday to make sure that a piece of furniture fit in my room, right? The first thing we did a little bit of sequencing, which is basically going and saying, here's how the problem that we worked on yesterday translated to. I'm gonna make these shapes a little bit smaller so it can fit in here, and you can see what we did yesterday. And then I'm gonna show you the code again so you can just see how our code turned into this nice shape that we have. So, okay, look how we translated the problem that we had. We went out there and we said, hey, sequencing, which is basically I went out there the first thing and I said, hey, define a class called room, right? So define room class, right? Define room class like this. Okay, that's sequencing. There's no magic there. And then I went again and I said, oh, take this piece again and also define furniture class, right? That's what I did. And then I went again and I said, okay, well, I have another thing in here that I want to define a a chair class. And then I also went out there and I said, well, look, all of this, I'm just building my statement out of these patterns that we just talked about, right? So let me pick up this guy down here and let's just go here and here. Okay, here it is. And then I went out there and I said, define a TV class, right? And then we went out there and we said, okay, out of all these classes, right, I picked up all of these like this, something very similar to this. And I went and said, define room instance, right? And define furniture. We didn't define a furniture instance, but we said define a chair instance, right? And then we went and said define a TV instance. Great. Now what? We set up the sizes on all of these. And now we said go ahead and iterate on every piece of furniture, right? We went out there and we said iterate on every piece of furniture that you have, right? Within our iteration, we basically went and said, check in here. This is a selection. We went and said, check if there is space left. And then based on the result, we determined whether, return a message about space left. That's our program yesterday. See how it translated into these patterns? See how it worked? We did find bunch of things, find bunch of things, and then we did a iteration, and then we did a little bit of, a check, and then we returned a message based on everything. Everything in programming that you'll ever see falls into these patterns. It's like when you, what's that language that people use to do the old language for the radio? Like they go like, tit, 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 tit. What's that language called? Is it Perel language? Morse code.
Mm,
Have you ever heard of Morse code?
no.
So Morse code is very interesting. Let me show you. Morse code is basically when people are communicates from the old days, and people used to communicate through Morse code. Here, Morse code. And people used to use Morse code to basically communicate messages to each other. So like every letter in the alphabet is
Mm,
like tit 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 tit, like with the radio, right? So each and every letter in the alphabet basically matches this Morse code, right? Except that in programming, instead of dots and dashes, it's dots and it's a circle and a rectangle and or a square, a circle and a square and a triangle. It's the exact same idea, except that instead of expressing just letters, we're expressing thoughts,
mm.
an entire structured thought in these exact very same terms. What do you think about that? Any questions about any of that?
Doing very good. So far, so good.
You better learn this. They won't teach you that in college, so this is really important. Okay, so there's that stuff. And then also I think, in for Perel language, which is, language for people with visibility issues, they can't see.
Mm,
I think it's called that. I don't know. Maybe I'm misspelling it. Let's see. Perel language. Yeah, there it is. Yeah, there you go. So you will see some buildings like for blind folks. I think that's what it is. No. Okay.
it's not pro, it's bro, I guess.
What's
B.
it called? Oh, Braille. Braille. Braille.
Right.
Sorry.
Yeah,
I'm super
try to
ignorant.
remember.
Braille. Yes. It's just, I'm sorry. It's just the
Yeah,
spelling and
close.
all that. But anyway, so if you look at these, they're following exactly the same idea, right? You're picking up some thoughts. So you're saying, see, these two dots on top of each other, it means but, and these two dots next to each other can, and then there's do, and then there's every, from, go, have, just. See, it's exactly the same thing in programming, right? And that's why programming is a universal language because you will find people from everywhere in the world, just like how blind people, people with visibility issues, visibly impaired, they can understand this language no matter where they are, what they are in the world, by of course by learning it. The same thing for software engineers. We have patterns, and these patterns express particular thoughts. And this is basically the idea that I'm trying to convey to you here today. This is basically the idea of expressing. But the one thing I want you to understand is that solutions are infinite, Sally. Thoughts are diverse. The problem of finding a place where to place a chair in a room, it could be written and solved in hundreds, maybe thousands of ways. So in software engineering programming, there is no wrong way or right way. There is many, many right ways, and there are many, many wrong ways in terms of whether you can bring about a result or not. Okay, is that very clear? So if your program works and it returns the result based on the tests, it doesn't matter how internally this program was built because it's not set in stone how you're supposed to be writing a program.
Mm,
You can express because it's as diverse as people thoughts are, and our thoughts are more diverse than anything else in the world. Are we clear on that? We good?
good.
Good. Okay. So what that basically means, let's jump back into code, right? Let's jump back into code and see. Let's today you and I gonna evolve our solution a little bit together. Okay, you're gonna help me out. We're gonna evolve our solution a little bit, right? So in this furniture solution here, we basically went and said, this is a room, and I want to know if this furniture fits my room, right? Now, let me ask you a question. What if I want to find out if the furniture fits in all the rooms in my house? So now I don't have just one room, I have many rooms in this house. And I want to know if all the furniture that I bought can fit in all the rooms in my house.
Okay.
How do we solve that?
So technically, you don't specify only, it doesn't matter which room it fits. So no matter
It
what,
doesn't
you
matter.
just want in a whole
Yep,
house, basically.
yep, yes. And I love that you just said that because a lot of engineers today, they create restrictions for themselves that were never mentioned in the requirements. Always stay true to the requirement. I didn't say the furniture is supposed to sit in a particular room. I just said, does the furniture fit in all the rooms in my house, irregardless whether these rooms are there or not, right? So how do we solve that problem? What do you
So
think?
basically, we don't have to even define basically you can change only room to house because the whole category of all the rooms is house, right? Except you want to divide it minus basically bathroom, maybe. So
Right.
basically what I thought, so I would define the house
But
or,
what if you don't have the option to have a house and you have room class and
okay,
you're
so
given a bunch of rooms. You're saying this house has 5 rooms in it.
how about we define the incident of each room and then we added up the whole space and then
Uh-huh.
compare it to that.
Great. So basically we want to allow entering a bunch of rooms in addition to a bunch of furniture, right?
Mm-hmm. Mm-hmm.
Ah, that's a great idea. And if that's the case, maybe instead of using params, we can create lists. So maybe I can have a list of furniture.
Mm-hmm.
List is just like params. It's
Okay.
just a different way to express the same thought. And then
Mhm.
instead of rooms, we can actually have a list of rooms.
Mhm.
Okay. Well, let's say you have now a list of rooms and a list of furniture. And I
Okay.
want to know if all the furniture that I bought would fit in all of the rooms that I have in the house. What should we do now? Let's put this on hold for a little bit. Let's start over. What do you think?
Mm,
Let's give this a plural name because it's furnitures and rooms, right? Okay.
mhm.
Hmm. What do you think? Mhm.
We should get the size of the rooms. So add in like basically.
Room sizes like this.
Mhm.
So let's start with 0, right? Because we don't have any rooms yet. Now, what kind of pattern can we use now to know the total size of all the rooms?
Basically we use the
Mm.
room plus plus or like the for loop because we're
For
gonna
loop,
have
iteration,
iteration.
iteration. So are you saying I have to iterate on each and every room in my house
Mhm.
and continue to add, accumulate basically
Mhm.
room size, room sizes equal the room size itself plus room dot size, right? Room sizes plus room dot size like this. So what this guy is basically doing now, it's basically going and saying, see, now you're expressing a thought. This is sequential. This is the square. And now you're going into this circle. And now inside that circle, you're going into a square again, which is a sequential statement, right? So in here, you're basically going and saying, let's define a, let's create a like a bucket where we can save all the sizes for all the rooms. And for every room that is being passed in, for every room that is being passed in, I want to go and accumulate so I can know the overall size of my rooms. Is that right?
That's correct. Mhm.
Okay. Okay. So by the end of this statement, we should know the overall size, the total size of all the rooms,
Mhm.
right? Now, what do we do next?
Don't you want to return it like to the get the output?
Return it. But this guy is telling me whether the furniture fits or not.
Oh,
So if
okay.
I,
So
uh, uh,
now we have to accumulate the furniture size.
aha. So what should we do here?
So
Mm.
again, the same thing. So in new like furniture size.
Furniture and furnitures like this. So
Mm-hmm.
do I just define an int in here basically that says furniture sizes like this? That's great. And I can go here and say maybe furniture sizes is equal furniture sizes plus furniture dot size. So now
Mm-hmm.
we have the total count of rooms, size of rooms
Mm-hmm.
across all rooms, and we have the total count of furniture. Now what? What should we do here?
Also compare them. So we have to
Mhm.
like we have the total. So we say if a statement basically.
Ah, now you're doing selection.
Then
Okay, now what should we say? If room sizes, you tell
this
me. Mhm,
is
mhm.
equal less than. Well, hold on. No, it's less bigger, not less than.
Bigger than. Okay.
Bigger and equal to furniture size, or no, not bigger. So because you don't want total fit, maybe, or
Mm.
maybe. So yeah,
Bigger than or lesser
yeah.
than? What do you think? Hmm.
Well, it depends on what the outcome it could. You want to what kind of message you want to do. So it could be both.
Yeah,
But
bigger than or equal. So what should we say? We say furniture fits in all rooms like
yes.
this.
Mm,
Okay. What about the other case?
else,
Ah,
then
else. That's right. Hmm.
so it doesn't fit.
Furniture doesn't fit in your rooms. That's it. Let's run it and see if it's true. So now my statement here has changed a little bit because now my signature, this is what we call a signature for a method.
Mhm,
Now this signature has changed.
mhm,
So all of these rooms that I have living room. I'm gonna create a bunch of other rooms like this. So instead of living rooms, I'm gonna say bedroom like this. And maybe I'm gonna say here bathroom,
mhm,
bathroom like this. Okay, so I now have a bunch of rooms. And I can now add all these rooms in a list,
mhm,
right? So let me simplify this whole statement. I can go here and say, all rooms equal new list of rooms. And
mhm,
for every one of these rooms, I can either pick up these rooms like this. There's many ways you can express one thing, right? So I can go up in here and say, hey, I defined all these rooms in here. Let me pick up the living room. Let me pick up the bedroom. Let me pick up the bathroom like this. And now I added all my rooms in a list of rooms.
mhm,
See, that's one way you can do this.
mhm.
Or you can even make it shorter. Like I said, sometimes software engineers have to turn into poets. They have to write things in a way that's easy on the eye. So some engineers might say, well, why are you doing all of this? Maybe I can simplify this whole statement by going and saying, new room, right, with a size of, 300. So that's one room. And then I'm going to define another room in here and another room in here. So now I don't need any of that junk anymore. I can get rid of all of this. And now I have maybe this room is 400, maybe this room is 100. That's it.
Mhm.
See how you can express the same idea in many, many different ways. The only problem with that is that you lose the name. And
Exactly what I wanted to say. Basically,
yeah, you don't
forget
know
which
which room
one,
is this. Uh-huh.
yeah, which one you did. So you measure
Exactly.
which one, and then
Yep. So it has its pros and cons. Sometimes you don't care, sometimes you do care. Okay.
mhm,
All right. So there's that part. And then we could do the same thing with the furniture. I guess we could just go here and say var all furniture. When I say var, I say it's the same type as the right side. So if the right side is list furniture,
mhm,
then the left side is type list furniture. Like if you go and hover over all furniture like this, it will go and tell you, oh, it's of type list furniture.
mhm,
So this statement and this statement and
mhm.
also and this statement and also even a statement like this are
Oh,
all true.
mhm,
Okay, so this is the furniture. Now I can pick up all that good furniture that I have in here and I can define it in top here, and I can go and say, well, here's my racer chair, here's my kitchen chair, here is my LG TV chair, and here's my bouncy castle chair. There you
mhm,
go. So I defined my rooms, and I defined my furniture. And now I can go use this awesome function that I built to go and say, here is all my rooms and here's all my furniture. Done. So I basically passed in this function, passed these variable to this function. And these variables basically are all the rooms, all the furniture. This guy is going to go in and do the magic for me, do all the routines, and it's going to tell me whether my code works or not. What do you think? Any questions about any of this? See how we wrote a really cool program? Go ahead.
Yeah, the thought is completely clear.
Wonderful. Let's run it. Well, you know, they always say talk is cheap. Show me the code. So here's the code. Let's see if we can, you know, run this code. So here's, what was it? .NET run project. And then it was Space Solver. And then I think it was this project. I hope it works this time. Well, looks like it's working. So, okay, so here we go. Furniture fits all the rooms. Right, now let's make our bouncy castle a little bit crazy. In order for us to know something that actually works, you know, we're gonna have to test it a lot. So let's make this 1,500 like this feet. Really big bouncy castle. The one they put there under buildings when people are planning to jump off, you know, to save them, you know. So let's run again and let's see what our program says. Ah, furniture does not fit in your rooms. What do you think about that? Does that sound good? Does that sound like a plan? So, so what do you think? Any questions about any of that?
So something just about syntax, maybe we'll dig into that. So the difference between list and array. So
Ah, so let's talk about that for a second. So list and an array. Let's create something far, far away from here. So this is void foo. You can store a list of things in so many different ways. You can go and say, here's an array of strings, let's say names, and here's a new name of strings, and I can go and say Sally, Hassan, and Josh, and Kailu, and all kinds of different people in there. The problem with this approach is that you can't add to this array. It's fixed. It's already defined. You can't do anything beyond that point, right? So if I go in here and say names, I don't know, maybe positions is 0, 1, 2, 3, 4 equals John, for instance, this guy's gonna blow up. It's gonna freak out. Let's test it together. Let's go and comment this code for a little bit, just for a second. And let's go here and call this foo function. Let's see what happens. So here's my foo function. I'm just calling it, right? And I need to make this function static. Static void. And we'll talk about static and what it means at some point in time. So, okay, so it's foo. So I'm gonna go up in here and I'm gonna go run my software and see what it does. Is it gonna add it? Nope. Blew up. It says index with outside the bounds of the array. Because you've already predefined the bounds of your array based on the size of the items that you passed in. So arrays are great, you just can't add on top of them from the get-go. What's a better solution than an array? Normally, we use lists. And now I can go and say, here's the name. So I'm going to just replace the existing implementation, but instead of string, I'm just going to say a list of string. Is a list of strings. The only difference here is that now I can go and say this list of strings, go ahead and give me added amazing functionality that allows me to add new items in here. Now, if I run my application again, it's not going to blow up because it has more power.
Nice.
See, so arrays are an option, lists are options. There are so many different options out there that we're going to discuss, and we're gonna normally what engineers use in general is something that we call iQueryable, and I'll explain that to you, or iEnumerable, or iCollection, and sometimes, very, very rarely, you know, engineers will use arrays. And there are things like dictionaries. There's so many different data types that I will talk to you about, you know, at some point in time. But for now, we're just trying to express a bunch of thoughts. Just a bunch of thoughts. Now, here's my suggestion for you, because we are nearing the end of our session here. So I'm gonna give you an assignment. Do you want to take an assignment? Are you
Yes,
interested in an assignment?
I
Okay, let's take an assignment. We're gonna improve our program a little bit, and then tomorrow you will be explaining to everyone here when we meet again
Mhm.
how did it go and how did you solve that problem. Okay, no Googling, no
Mhm.
looking online, just try to express your own thoughts through code. So I'm gonna copy this code here and I'm gonna put it in a new jest for you. So I'm gonna go up in here. Let's go to, let me share my screen here. And then let's go into GitHub and let's create a jest. New jest, right? And this is modeling simulation 002. Here's the code, right?
Mhm.
What needs to happen really, and I'll explain this requirement for you because that's what all the software is, problems that needs to be solved, and we're using code to solve these problems and making them work. Here's what we're gonna need to do, Sally. Let me create this gist for you. It's not a secret gist. I'm gonna make it publicly. I'm also gonna publish it on YouTube as soon as the session is over. What we need to do, my friend, here is that we need to go and say, if the furniture doesn't fit, we want to know why it doesn't fit. Like which piece of furniture that we're trying to add in that didn't allow us to kind of fit that furniture in the rooms. So for instance, let's say for instance we have a 5 chairs
Mhm.
and 2 TVs and maybe a bouncy castle. And we were doing in the first jest, we were adding them one furniture at a time, and we're checking for each piece of furniture whether that piece of furniture will allow us, will allow us to have a it in the room or not. And if it doesn't, then we go out there and we say, sorry, the furniture doesn't fit. We want to improve our program a little bit. We want to tell the people that are furnishing their house which piece of furniture that we couldn't fit into their house.
Mhm.
Okay? So that's your assignment. You're going to have to figure out how to improve the program and reflect your thought. Now, before we just, end the session, how would you go about, like, without even looking at the code, huh? How would you go about solving a problem like this? Let's just see if you have the thought, the algorithm, the solution for the problem.
Yeah, that's like I was thinking always the last one doesn't fit, right? So
Mm-hmm.
basically you have to all the way uh
It doesn't have to be the last one though. Like
yeah.
you could have 5 chairs and at the third chair it couldn't get in because it already exceeded your space.
Yeah, basically I'm talking about the maximum size.
Uh-huh.
That's the size of the minimum, like one of the biggest items. So you
Uh-huh.
have to at least the whole room minus that one. So
Uh-huh.
basically, I'm checking about the size of all my furniture, which one is bigger. Basically, I kind of organize that,
Mm-hmm.
and, and basically maybe I can fit around the biggest one or smallest one, and then just subtract the whole size from one biggest item. I have one room left, and then from the rest, I I can tell.
Mm.
Well, maybe let me think more about it because
Yeah, I'll let you.
but
I, go ahead.
it's kind of can you repeat the question? So you want to know which one didn't fit or why is not fit?
Yeah, so why it's not fitting basically is it's very much the same thing. I want to know, okay, I bought this big house and I want to know, I bought in a chair. Let me zoom in a little bit. So I
Mhm,
bought in a chair, let's say chair 1, chair 2, chair
mhm,
3, chair 4. Oh, I'm typing chair wrong. 4, chair. Yeah, there you go. Bunch of chairs. And then
mhm,
maybe TV 1 and TV 2, right? And maybe PlayStation, an Xbox. I bought a bunch of things, right? And each one of them, of course, has a size.
mhm,
So we are fitting in the furniture in there. And I
mhm,
want to know the question here, which piece of furniture, it could be pieces, Doesn't
Mm-hmm.
have to be one piece. Which pieces of furniture we couldn't fit in?
Yeah, but this also depends on from which item you start fitting, right?
Yeah, and it doesn't like you're adding the items through a list. Let's say you have a van coming in front of your house, like a
Mm-hmm.
truck,
Mm-hmm.
right? And people put in the items in that truck.
Mm-hmm.
So it's last in, first out, right? The last item that they put on that truck is the first item that will come out,
Mm-hmm.
right? So as they're bringing out these items, they're coming in some order, whatever that order is, they're coming in some order. And they're
Mm-hmm.
adding in one after one until they reach to a point where there is no space left. So
Mm-hmm.
I go and ask the person, imagine this, this guy that I hired that is trying to put in the furniture in my house. Imagine I go to them and said, "Hey, which ones you couldn't fit into my house?" Which ones you couldn't fit into my house. So I determine whether I need to put them in the garage or replace them with a new item. We're gonna we're gonna go far with this problem. We're just starting really, really small. And by the end of these sessions, as we're learning programming, we will basically build a system that will allow us to kind of fit furniture into particular rooms with a particular angle. It's gonna be really fun.
I
But for
really
now,
like the question. Well, one thing. So, for example, if your chair one and Xbox would be the same size, but you start fitting up to like from chairs, and then Xbox doesn't fit, then your question, oh, why is not fit? Would you say like Xbox is not fit? Why?
yeah,
Because the size wasn't enough. But
yeah.
it could be like chair one, right?
Mhm.
And because chair one exactly had the same size of Xbox, so it's not a like a good answer, right?
Yeah, it's not about the size. We just want to know. The size is not the problem. The size is helping us know when we have reached the threshold, the maximum size.
Mm-hmm, mm-hmm,
But
mm-hmm,
moving forward, I just want to know which items, like let's say they move chair one and chair two and chair three and chair four and TV one. Oh, reach TV one, they reach the maximum
mm-hmm,
capacity.
mm-hmm.
Now, the answer that's supposed to come out when I say which pieces of furniture we couldn't fit in, it should be TV2, PlayStation, and Xbox.
Okay, now I got the question. Okay,
Yes.
sounds good. Now it's clear what you are asking.
Yes. Yes. So that's the idea. This one
Mhm,
you're gonna need to think a little bit about your data structures, about your classes, but
mhm,
also additionally you're gonna need to think about, remember, use use these three powers, superpowers in programming: iteration and selection and sequencing, and see how you can express the idea of this. Like if I were to solve this problem, I would go and say, keep pushing furniture in the house until there is no
mhm.
space left, and then see which items weren't added in the house.
Okay,
That's how you would solve it, right? See
mhm,
which items
mhm.
weren't added in the house. How do we express this in in terms of iteration, sequencing, and selection? And then how do we turn this into code?
Okay, sounds perfect. I love the question.
Okay, so I will give you this in here. I will give you this in here. Here's the problem, and I already just pasted in the chat. And I hope the people watching this as well, they're gonna try to do it themselves. If you're new to programming and you want to see, feel free to drop, in the comment section, your solution to this problem. If you're seasoned, thank you so much. I know you know how you solve this problem, but if you're starting to kind of learn about programming and all that, I highly recommend you kind of take a look and see if you can solve this problem. Sally, any more questions for you before we wrap up?
Great. Thank you so much.
Everything is clear? Okay, thank you so very much. I'll talk to you tomorrow. Thank you guys for watching. Don't forget to like and subscribe. I'll talk to you later. Take care, Sally. Bye.